Right. So let me share my screen. Somebody was asking about doing a COG app to look at testing the movie search CLI script. And I've talked to a couple of people about this kind of independently. It seems to keep coming up. It is a little bit of a different kind of problem to solve. So I thought it made sense to throw that out to more people. Looks like many of you are interested. So what I'm going to do is I'm going to start with my implementation of the movie search CLI app. So I've got the app built, and I just kind of blew away the tests in this no tests branch, and we'll look at a couple different ways of writing the tests from scratch. And let me just make sure I've got the chat thing open in case y'all are typing in there. And as usual, please stop me, slow me down, ask questions. Just jump in if there's something you don't understand or want to know more about. So let's start by looking at the, I'm just going to look at this directory real quick. So I've got, the code here is in the source directory because I've got Babel installed in this code base. Then it kind of compiles over this lib directory. So everything is, instead of at the top level, it's just in this source directory. So you'll see in source, there's a imdb.js, which is the code, and then there's like a testing directory where our tests are going to live. So I'm going to open up the code just so you can see that. I'm not going to spend a whole lot of time in here because we're going to focus on the testing. We're just in here long enough to see that there's a query imdb, which is the main method, takes in the search string, and then provides a callback. This will get called with the results down here, or with an error, if there's an error. And that handles the like talking to imdb. And then there's this other method, parse results page, that actually takes the raw HTML that comes back and uses Cheerio to parse out the names of the movies and kind of return them as an array. And then run is just the thing that parses the command line arguments and calls query imdb. So how are we going to test this code? Anytime your code is reaching out and interacting with a third-party service that you don't control, or even another internal service that's just not part of this code base, testing can get kind of complicated, right? Ideally, you want your tests to be reliable, to always run exactly the same way, and in an ideal world, not need to be connected to the internet or not depend on IMDb not being down for maintenance or that sort of thing. So it gets kind of tricky. So we're going to look at a couple ways to approach this. So let's see, I've got a test file here. So here's my test file up above. And I'm just pulling in chai and the query imdb method. And so, so let's start by doing the, what I like to call the naive thing. Usually when I'm trying to solve a hard problem, I'll start out by just doing like the simplest thing I can think of, and then improving on that. So let's just start with that. Like, what's the simplest thing we could do? Well, let's just call the method in the test and test it, right? And not worry about the implications of like the fact that we're calling out to IMDb on our tests. So if I want to say this test can find Nemo, so let's give that a shot, right? I've got my query IMDb method, right? And it takes a search string, so I'll call it with finding Nemo. And then it takes a callback that gets called with an error and the result. Just like most node callbacks. So I can just call this method, and then inside the callback, I can make assertions on these parameters getting passed with the callback. So I can say I should expect that the error is null, and I'm going to expect that the result has length greater than one, right? There's at least 2 Finding Nemo movies. We can see over here on the right side that there's like a whole bunch of them. So I could even look at this 1, 2, 3, 4, 5, 6, 7, 8. So let's say we're going to expect to have length 8. That's really what we want to say. Let's see, can go away. And then we're going to call done here, right? Because I'll just have it in a callback. So we need at some point to tell Mocha that like we're done, all our callbacks have finished, and it can complete the test. So let's give that a shot, right? I'm going to just back out of my editor here and run npm test, which I may need to set up correctly. To source test. No, that looks right. npm test. So I'm getting an error. I'm getting an error in my package.json because there's an extra comma. That's what I get for changing things right before a demo. Okay. But the package.json fix. Okay, so there are tests. The tests run. You can see it took half a second to run that one test. And in a good-sized application, you'll get a test suite that has hundreds of tests, maybe even thousands of tests. So taking half a second per test is not ideal, right? Your test suite would take forever to run, and that does become a problem with large applications. And it took half a second to run because it had to, go contact IMDb. But the good news is that it works. We think it works, and I've said this before in other contexts, but if you've only ever seen your tests pass, like don't be too confident in those tests, because I could just comment out these 2 lines and the test would still pass, right? Tests pass for all kinds of reasons, especially like, the callback never get called and the test could pass. So you always want to just verify your passing tests by forcing them to fail, change the expectation a little bit. Just to make sure this is working. There we go. So it does fail because it gets 8, and if we expect 6, the test is going to fail. So, so that is the like the super easy way to write tests for this, right? Just call the method, put the expects in the callback. It's a little tricky because like asynchronous things are happening, so you have to put your expectations inside this callback that you're passing to your own query method. Which means that you have to write your query IMDb method to take a callback, which you would really need to do in most circumstances for it to be a useful or reusable method, right? If your query method is just printing out the results when it gets them, it's going to be really hard to test. And it's also going to be really hard to use in other contexts in your application, right? You're probably going to want to query the results and do other things with them besides print them to the screen. So that is, that's the first way, right? So what are the problems with this? Like I already said, we're reaching out to IMDb, which is slow. It's also unreliable. IMDb could be down. It also means that if you're developing and you're not connected to the internet, the classic example is like you're on your way to some conference and you want to hack on your app in the airplane and you don't want to pay $15 for Wi-Fi. Like, you've got all your code on your laptop. There's no reason you should have to be connected to the internet just to run your tests, unless your code has to reach out to IMDb just to test itself. So that's going to be annoying. So, so what are some other options, right? Let's call this the easy way. All right, so that's the easy way. So what else could we do? Well, one solution to this problem is unit testing, right? Testing this whole thing as a chunk, right? We have to like cover this code that does this HTTP GET and talks to IMDb. But if we look at this code down here, really except for, all the code that doesn't have to do directly with like hit this URL and return the results is pushed down into this parse results page function, right? So we have a function that takes the raw HTML that we got back and translates that into an array of movie names, right? Kind of parses that HTML. So one thing we could do here is just export this function as well and write unit tests for that, right? Parse results page. So let's pull that out as well. And let's do another one of these and call this unit testing. So if we're going to unit test this, we don't call the query IMDb method so that we don't have to actually hit the IMDb server, but we call this helper method directly. And we write tests for parse results page. And we're going to pass it in some HTML. And let's keep these tests, right? That's useful. Done we need, right? So we can, so now we just need to define this HTML, right? So what is that going to look like? We can look at the code, right? And we can see that, well, we're looking for something that has a find section class. We're looking for the first one of those in the page. And then inside there should be some things with result text class. And we're just pulling the text out of those elements. The other way we could do it, instead of reverse engineering that from the code, is actually to come over here in the results page and look at the HTML of the page and say, okay, what kind of HTML are we parsing? So, and we can kind of see in here, if I inspect the right thing. So here's that find section div. And there's, a few of these. The first one is the movies, which we're interested in. And then here's the find result table rows that have a result text table data. So what we can do is just hard code some HTML into our test to parse, right? So say we have some HTML that's got, let's see, it'll have a div with a class of find section. Find section. And then inside there somewhere, there's this table. Can't spell table. And then inside the table, there's some table rows that have some table data with a class of result text. And then there'll be some examples in here, right? Like finding Nemo from 2003. Table row, close that off, and then this table has to end, and this div has to end. So, so that kind of looks like the HTML when you tend to parse, right? And this will have a couple results, finding Nemo. All right, so we can have a bunch of sequels. And then probably just to make this a more interesting test, we should have another find section div in here, right? Just to make sure that our code is pulling things out of the first find section and not the second one, right? So we could even put some results in here to make sure these don't come back. So this could be the, what are the other sections? I don't remember. Keywords. Yeah, anyway. So we can just hard code some HTML in the test, right? Pass it directly to the parse results page function, and then just check the results to make sure that it has the right attributes, right? So here I could say expect length to be 3. I could even go further than that, right? And I could just say expect results to deep equal this array of stuff, right? It should be these names. So I should be able to just put some commas here. All right, so it should be exactly those three things, right? That's what that HTML should parse to. So let's run those tests. Boom. Right, so those pass too. And again, never trust a passing test. Let's add something here and make sure that I actually wrote these tests right. Right, so it fails. It fails if it doesn't find something it's expecting. That's good. The test is working. So, so that is method number 2. Get that on the whole screen there, right? So unit testing, we sort of break our code into smaller, more easily tested pieces, and we test those pieces. And let's talk about pros and cons of this approach, right? This is nice because this test runs, as we saw, super fast, right? It's so fast that Mocha doesn't even print out the runtime for us down here because it happens in like super, super fast. Mocha is still giving us this red warning up here about like, man, that test is slow for the easy way, but unit testing is fast. You know, it's a nice pure function, so it's super fast, it's easy to test. I don't have this external dependency. So those are nice. And writing tests this way also sort of forces me to write my code in a way that is modular, which has a lot of other benefits. Code that's easy to test like this kind of has a lot of pure functions that do a simple thing, a simple transformation from A to B. And that the type of code also tends to be easier to work with. It's easier to come in and make changes to because logic is sort of isolated. So if we look at the source for this, right? We have this one function and all it cares about is like translate HTML from one thing to the other. So this is really nice, right? If I want to change like where we're getting the HTML from, I want to use a different IMDb search page, or I want to like, you know, download a whole database of the IMDb search page results and then like parse them offline somehow. Like this is just disconnected from any context of like where the HTML came from or what's going to happen to the result. So it has nice side effects on your code. When you're writing unit tests like this, it tends to force you to write better factored code. What's the downside of this? The downside is this file is 45 lines long, and I'm only testing about 8 lines of it, right? I'm testing this code here in my unit tests. The rest of this code is just untested. So if there's a bug in the way that I'm constructing this query to IMDb, my test will still pass, right? And we can show that if I just if I tell Mocha to skip this test. I don't know if you've seen this, but you can add a .skip or a .only to a describe in Mocha, and it will skip that test or it'll only run that test. So doing the skip, well, actually, I'll just leave it in. It doesn't matter. We'll run them both. But if I come in here and if I break this, right, and I change imdb.com to imdb.org, and then run the tests, the easy way, in all its slowness, actually breaks, right? So I get some feedback that, hey, you've got a bug. My unit tests don't show that bug because they're not covering that code. So that's the downside of the unit test approach. Not that unit tests are bad, but if you're doing unit tests because there's part of it that you don't know how to test, you know, it still doesn't solve that part. This part is still just untested. And sometimes that's okay, right? You're not going to get 100% test coverage in your code, and you shouldn't try to. You're going to get to a point of diminishing returns on testing. So you may just decide that, look, this code is pretty simple and straightforward. It's hitting a URL. It's unlikely this code is ever going to change, or it's going to change very rarely. So if I can prove to myself manually that it works, then I don't need automated testing around it. And maybe that's the decision you make. But looking at this code, it is a little hard. I mean, there's kind of a lot going on here, right? There's like all these query string parameters, and like it'd kind of be nice to have that tested. So what if we're not satisfied with these two options, right? Or not just these two options. We've got our unit tests, and that is nice. And we've got this easy way, which is kind of an integration test, right? It covers the whole thing, but we're still tied to IMDb, and this test could still fail if IMDb goes down. So let's look at a third way. And we are going to call this way, let's look at something called knock. So I'm sorry about the loud phone. I'm in a co-working space, and my office mate likes to leave his phone on his desk when he's not here. Okay, so knock. We're going to use something called knock. So knock is a mocking library. It's an npm module, npm knock. My npm.js website. So let's go install that. I'm going to npm install save dev knock. All right. And let's see. So that's installed. It's added to my package. Let's come back in here. So now we can import knock from knock. So what knock does is it allows us to basically hook into npm's default HTTP GET method and fake it out. So it basically, knock allows us to intercept any HTTP requests that our application might make. And instead of actually sending those requests over the internet, it just sort of intercepts them and allows us to say, hey, if my application tries to make this type of request, just automatically return this response, which sort of removes that dependency on the internet and like a third-party site. So it's a nice thing to use when you're dealing with a third-party API or a third-party website like we are in this case. So let's see what that would look like, right? We want to have our it can find Nemo test again, and we're gonna do this same thing here, right? So I'm gonna copy this test verbatim, actually, right? So we're gonna do the same thing where we are just calling the top level method, covering the code that's gonna try and talk to IMDb. But before we actually call query IMDb, we're gonna say knock http://imdb.com. So here we're saying intercept any requests to imdb.com. And then we can kind of get more specific here and say what we want to intercept are get requests to the find path. And if we look in the code here, you can see that's what we're hitting, right? We're doing an HTTP get to imdb.com with a path of /find and then this query string with these different parameters in it, right? So I can just say, look, knock out any requests to imdb.com/find and reply with a 200 status code and some HTML, right? So the second argument to reply here is going to be some HTML to return. What HTML should we return? Well, it's kind of handy. We have this thing already written down here. Let's use that. Let's grab that HTML and we'll just, I'm actually going to just do this in line here. So we're going to reply with this HTML that we've already written. So we kind of know this thing works, right? So here we sort of mocked out this request. And then we're just running the query like normal. And when our code goes to do HTTP GET, that GET will get intercepted and this stuff will get returned. So and in this case, right, instead of having 8 results here, we should expect 3 because we should be hitting our knocked out response, not the actual live page. So if I run the tests again, we should see a new group of tests in here. Knock it out, and those tests fail because expect the length of 3, but got 8. Around. So that is tricky. It's still getting 8. So something about the way we've knocked this out is not working, which could mean that I've misspelled something. http www.imdb.com/find reply with 200. That is very interesting. Oh, right. So this is the one thing we forgot to do. I think this is going to fix it. One thing that you have to do with knock. So once you install this knock, you've sort of added that like intercept, right? And so any future tests or any other code that tries to make a GET request is going to keep hitting these knocks. And so we do need to add a knock clean, which looks like somebody just put in the chat room. I don't know if this is the bug we're hitting, but it's worth trying because it's going to have to be done. So knock provides this method, knock clean, which basically unregisters all of its hooks. It just kind of takes its grubby little fingers out of HTTP GET and restores it to its normal operation. So you want to put a knock clean either in a before each or an after each. I kind of prefer to do it in after each. So it just kind of cleans up every time. After, you know, because we're sort of like setting this mess up here and then we run our tests, we want to make sure that we kind of clean up after ourselves. Let's see if that makes any difference. I have a suspicion that it's not going to fix it. Default clean is not a function. What? Sure it is. Restore. It's a knock restore. Sorry. There it is. Okay. So we're still getting this error. And I don't know why. Expected an array of 8 to have a length of 3, but got 8. So somehow it seems like this request is not getting intercepted and is finding its way all the way to IMDb, which is wrong. See if I can figure out without taking too much time what's going wrong here. Person to thing, knock, get, /find. Huh. I have to say I'm a little stymied by that. Let's see if it has anything to do with these other tests. Just run this test all by its lonesome. No. Expected to have a length of 3, but got 8. And we log that result. I'm pretty sure it's going to be the result from.
Hey Trevor, is it maybe that the path is wrong? Like instead of just find, we need the whole find ref equals that whole search.
That's a really good question. It shouldn't. So the way these things work, it should, like, if the first part of the path matches, it should work. But that's worth checking. I walked through this example on my own before I did this, and my like sample code that I know was working 30 minutes ago did it this way. So I'm really confused. Someone's asking if clean all is going to be, going to work the same as restore. Clean up all the prepared mocks, some state after failed test like this. Let's see what the difference between clean all and restore is. You can restore the HTTP interceptor to the normal unmocked behavior by calling restore, but it does not clear the interceptor list. Use not clean all if you expect the interceptor list to be empty. Let's try that. Yeah, one way or the other, I don't think that either the restore is the thing that's causing us issues here. I think so. It could be something about that query string. Let's consult our documentation. Find. Let's see, specifying a path. The request path to be a string, regular expression, or a function. Any HTTP verb. Text of cats. Yeah, so specifying the query string is something you can do separately, like this. So we could try that. It's worth trying. And we can see that our query string is this stuff here. So, and the search is going to be Finding Nemo. Let's see if that's any better. Yeah, still not happy with me. All right, well, I'm not exactly sure what the bug is I have in here. So I think I'm going to, we may move on, and I will try and debug this on my own so you don't have to sit here and watch me poke at things and not figure them out. I'm not exactly sure what's falling apart here. It's probably something small. This is roughly how it works. Yeah, that is frustrating. I've got an example checked in my GitHub branch that does work. So I can post a link into the Face channel after this so that you can see code that's actually working, and I will try and figure out what I've done differently this time. But knocking, using a knock or another mocking library like this is another way to do this. Knock is a pretty robust, like, HTTP request mocking library we've used here at Learners Guild before. And that's another way to do that. Someone's asking about the backticks. So backticks are another quote operator in JavaScript, right? So you've got single quotes, double quotes, and backticks are your third option. And the backticks just have a little bit of special behavior. Backticks allow you to do this variable interpolation. So inside a backtick expression, you can, inside backticks, you can use this $ parentheses and put JavaScript in there. So you could, have a string that's like 1 + 1 =, and then like actually compute that value here. That's not a great example. But the point is that this string would end up resolving is equivalent to this, right? That the stuff inside the brackets gets evaluated as code, and the result gets like put in the string. So it's a way to stick variables in a string, right? If you have some variable, you could do things like this. Hello name. So it's one of the things that the backticks give you. The other thing is they work better as like multi-line. If you want to do a multi-line string, so this HTML, I didn't want to put all on one line. And you can use the backticks to declare a multi-line string. And that may work with the single or the double quotes. I'm trying to remember why I have the habit of using the backticks. I think there are ways that with the single and double quotes, things get a little wonky when you try and do multi-line strings, but the backticks are a little friendlier with that. Oh, the variable in the H. So yeah, there's no variable in the HTML string. It's just because it's a multi-line string that I'm using the backticks. That's like the second usage for the backticks. Okay, so there's one more way to do this that I want to show you, which I think for this application is actually my favorite. So knock is one, unit testing, just the parts you can easily test, is another. Just throwing up your hands and hitting IMDb every time you run your tests is another way, not recommended. The last way is something called Sepia. And with Sepia, we're going to do the same kind of thing again here, where we run our tests. And in fact, here's the cool thing about Sepia. I actually don't have to write another test block for this. And I kind of forgot. Let's go install Sepia, and I'll pull it up here. Sepia, and npm I save dev Sepia. So Sepia is a module that it does something similar in that it intercepts HTTP GET requests that are made. But what it does is it adds a little bit more functionality on top of what knock does, for instance, to save you from having to write these big chunks of HTML yourself. And this is, I guess, we should talk about the downsides of doing knock this way, right? So when you're knocking an external site like this, it's a little bit more to set up, as you can see. And also, we have this HTML that we've hard-coded in here. And so if IMDb changes the format of its search results page, for instance, our application would break, but our tests would not start failing because our tests are sort of locked in here. They're assuming that IMDb never changes, right? We have to come and manually update our tests every time IMDb changes, which is really the only option we have if we're not going to hit IMDb live. But it is it's a lot to manage. And this little snippet of HTML we have here isn't exactly what the HTML of the results page looks like. It's equivalent, right? But the actual results page has a whole bunch more stuff in it. It's got a bunch of anchor tags in here that we just sort of ignored. So this isn't a very accurate representation of what the actual search page looks like. And so we're sort of balancing out, like, how much raw HTML do we want just sitting in our tests versus how much accuracy do we want? So Sepia solves some of those problems for us. And the way Sepia works is you just import Sepia. We don't actually need anything from it. We're just going to import it or require it. You could also do require Sepia. I'm just using these ES6 import syntax, but these two things are equivalent, right? So you just load it, and it registers some stuff in the background and starts listening to all HTTP GET requests. And then what we're going to do is and I'm not sure how these things are going to play together, so I'm actually going to comment out this knock stuff for right now. So I'm not sure if we have both things trying to intercept HTTP GET requests, some bad things can happen. So let's pull knock out. Let's call this Sepia now. So those are the only changes we're making to our test file. And that's actually all you have to do in there. And then what we're going to do is we're going to save that, and we're going to go into the package.json where we're running the test script, right? So this is the test script we run, Mocha with some compiler options for ES6, and then we point at the test directory. So what Sepia does is it looks for an environment variable in like the process environment, right? And it looks for an environment variable called VCR mode. VCR, like your old video recorder, right? And by default, we're going to set this to playback. Actually, I'm not going to change it in here yet. Let's go play with it first. So we'll just do it right here on the command line. VCR mode equals record. So if we run these tests with npm test with VCR mode set to record, the test will run like normal. They'll work, right? It's slow because it went and hit IMDb. But if we do a git status now, git stat, no, there we go. We should see that, no, come on, work with me here. Fixtures, there it is. So there's this new directory here. There's this fixtures directory in this repository. And if we look in that fixtures directory, there's another file called generated. And in here, there's these files. There's header files, and there's this other file. And they have these like weird long names. And if we look at one, let's just look at the first few lines of one of these. What do you know? It looks like HTML. Let's dump the whole thing out. So what Sepia has done is it's intercepted the requests that were made. And it takes the URL and the path and the query parameters and all those different options, and it generates this unique hash for them, just like Git does. This should look a lot like a Git commit hash, and it's using a very similar algorithm, right? To kind of take all the unique bits of the request that was made, generate a unique hash from it, and then store that as the file name for the result. And then what you can do is run the tests again and change VCR mode from record to playback. And the test will run.
We're working on that right now.
Mm-hmm. Why don't things work? There we go. Playback. Let's try this one more time. I'm just going to remove these fixture files. And so we should be able to say record VCR mode. Did I spell that right? Yeah. So I run them with record. And
okay.
You know, sometimes.
All right, let me find out because somebody's about to get a check.
Sometimes I just don't understand computers.
All right.
We imported Sepia.
Yeah, but see, the lender,
Life is just not fair sometimes. Sorry about this, folks.
in the process of sending.
Let me look at my example again. What did I miss?
Okay. That was the address
Finding Nemo, getting the results. We imported Sepia. This worked just a minute ago too, right?
You're saying that
we said VCR mode, record, npm test, and it records. Where are my fixtures? R-E-C-O-R-D. Okay, let's look at some documentation. Am I doing this right? VCR mode, record. VCR mode, playback. And I did install it, right? Did I do the npm install? Package JSON. There's Sepia. Oh, you know what it may be is that I need to maybe need to take knock out of there altogether. I'm not sure. Let's make sure that we got everything installed correctly.
Well, all right.
VCR mode, record, npm test.
So it's not an issue. Okay? It's just like tomorrow you will have
there we go.
$944 for per diem plus $150 for gas.
I do not understand why that's not working.
And we just paid.
Maybe try uninstalling and reinstalling Scipia.
Yeah, that's an option. Install Sepia.
And the only way that the limiter's going to do it right now is a reference to the approval of the advance that's been approved. Right now, there's two travel. There's going to be two travel things that we're going to do at the end of the month when you get back.
Okay.
We can't bill for the filing trip until the end of the month. So we're going to do filing and your travel in reference to.
Still not working. Okay, so here's what we're going to do.
And everything like that. At the end.
I'm going to.
So we got this thing.
This thing.
As far as your travel goes. I can assure you, anybody else that's traveling for a company,
okay,
they're going to have their own credit card.
Here's what we're going to do. We're going to go over to the branch where I've already got this working. Let's look at those tests. So here I've got tests, IMDb test.js.
I understand that.
Okay, so we've got Sepia imported. We got this sort of general test, which is just like we saw in the other file, right? Very similar test. And then in the package file, I've got two different testing scripts. One sets the VCR mode to playback, and the other one sets the VCR mode to record. And so if I run npm run test record, it'll run it with that record thing set. Can't find module knock because we need to npm install because I changed branches.
All right.
All right, so here we're getting timeouts because IMDb is being slow, most likely. Try that again. There we go. So there's a default 2-second timeout for Mocha tests. If the done thing doesn't get called within 2 seconds, it just bails on you. So sometimes IMDb is a little slower and we time out. But the second time it worked, we'll see all that stuff in the fixtures file. Fixtures generated, right? And then if we run npm test like normal, which sets the VCR mode to playback, the test should run a heck of a lot faster, but they don't. I'm not sure why those tests are so slow, but theoretically those tests should be hitting the fixtures in this directory. So that is the basic idea behind Sepia. It's basically doing the figure out what the HTML on the page is and then store it for you. And it just puts it in a separate file so it's not inline in your test. And it gives you a really easy way to update that HTML so that every month or so you could come in and run your tests in record mode to sort of pull down the newest version of whatever IMDb's results page looks like and update your fixtures with it. And then you check in your fixtures with everything else in your code base, and they're just part of your test suite. They're just like test data for your test suite. So Sepia and knock are two things to look into. And the other thing we looked at is just like doing some unit testing. And I'm sorry for the bugs in getting knock and Sepia working. Just goes to show you that once people are watching you type, everything starts to break. But I think that this repository I've got posted, everything should be working in there. So I can post that link in the chat room for y'all to take a look at for those of you who are interested in digging deeper into the code. Awesome. And that was just about an hour, so the timing is about right. Did anybody else have any questions or anything like that? How long until this will be uploaded? I will try and start the upload after this. I think I have one more video from yesterday I still need to upload. So both of those should be up in the next hour or so. And I'll post something when they are. Thanks for showing up, everybody. Any other questions, comments, concerns? witticisms? No? All right, great. I will see you all around.